So in November of last year, the act of typing computer code was effectively solved.
Yeah.
Like, just let that sink in for a moment. We are looking at this landscape where the fundamental building block of the digital age, which is, a human being sitting at a keyboard manually typing out syntax line by line,
Right.
it's rapidly becoming obsolete.
It really is.
So today's deep dive is based on a piece of source material from a YouTube channel called Beyond Coding. And it's this incredibly candid, almost startling conversation featuring two tech industry frontrunners.
Yeah, Jerome Gordine and Jerome D.
Exactly. And right out of the gate, they make a claim that should honestly stop anyone in the technology sector completely dead in their tracks.
Oh, yeah.
They say they have essentially stopped writing lines of code entirely since late last year.
It is a stunning admission when you consider their backgrounds. I mean, these are individuals whose entire professional identities, their reputations, and frankly, their whole careers have been built on an intimate understanding of complex programming languages.
Yeah, they're not just casual coders.
Right, exactly. To openly state that the physical act of typing out that code is now an unnecessary use of their time, well, it points to a fundamental rewiring of how software is built.
Okay, let's unpack this. Because if the top developers aren't typing code anymore, what exactly are they doing all day?
That is the million-dollar question.
Right. So our mission in this deep dive is to dissect a very critical distinction our sources make, and that's the difference between coding and engineering.
Yes.
We're going to explore how AI agents are transforming the mechanics of software creation, what it means to build software in a so-called dark factory.
Which is a wild concept.
It really is.
Yeah.
And ultimately, how this paradigm shift is going to restructure the future of human work. And the most crucial takeaway here is that this is not just some localized event for Silicon Valley.
No, not at all.
This is coming for every industry, every mid-sized business, and basically every spreadsheet you currently is using.
Precisely. And to understand the magnitude of this, we have to start with that core paradigm shift that guests emphasize. They argue that software development, which they strictly define as the physical manual act of translating logic into syntax on a screen.
Like the actual typing.
Right, the literal typing of brackets and commands. They say that is a solved problem. But software engineering is a distinctly different discipline, and it is far from solved.
I think the average person uses those two terms completely interchangeably. Like, if you are coding, you are engineering. If you are engineering, you are coding. So how are these two experts drawing the boundary line?
Well, the boundary line is drawn between conceptualization and execution. According to the source, engineering is about the overarching systemic decisions.
The big picture stuff.
Exactly. It's asking the structural questions. So if we're building an application, where do we store the artifacts? Are we deploying this infrastructure on Azure Cloud or maybe Amazon Web Services? How do these distinct complex systems integrate with one another securely? What is the fundamental architecture of the solution we're actually providing to the user? That is engineering.
Okay, so what is coding then, in their eyes?
Coding, conversely, is merely the mechanical translation of those high-level engineering decisions into a specific language, like Python or JavaScript, just so a machine can compile and execute it.
Wow, okay. That distinction makes a lot of sense. It actually reminds me of building a physical house.
Oh, that's a good way to look at it.
Yeah, because for the last 40 years, software developers essentially had to be both the master architect and the bricklayer.
Yeah, they did everything.
You had to design the blueprint, but you also had to get on your hands and knees and physically mix the mortar and lay every single brick.
Yes, perfectly said.
But what we are seeing now is that AI agents have become world-class bricklayers. The AI is laying the bricks, putting up the drywall, installing the windows. That physical labor is the coding. But the human still absolutely needs to be the architect. You have to be the engineer, deciding where the plumbing goes, ensuring the foundation can support a second story, and dictating how the rooms flow together.
That structural analogy is perfectly aligned with the source material. And what's fascinating is the psychological toll of transitioning from a bricklayer to an architect when you spent your whole life laying bricks.
Oh, I bet.
Yeah, one of the guests shared a very candid anecdote about when he officially stopped coding, which is around September or October of last year. He described it as a real struggle to break his own ingrained habits.
I can imagine. I mean, if you've been doing something one way for 20 years, your brain is just hardwired to solve problems through that specific physical action.
Exactly. He talked about looking at his monitor, seeing an error in the application, and catching himself actively reaching for his keyboard to manually jump in and fix line 12.
Just pure muscle memory.
It was pure muscle memory.
So it's almost like a physical withdrawal.
Very much so. He had to actively force himself to pull his hands away from the keyboard, step back, and resist the urge to just type the syntax.
That sounds so frustrating.
It was. Instead of typing, he had to figure out how to engineer a prompt or a set of instructions to guide the AI to identify and make that fix on line 12.
Right.
It was a highly frustrating learning process initially because, well, it felt slower, but it forced him to elevate his thinking. He had to learn how the tools work on a much higher level of abstraction.
And you know, the reason I want to linger on this for the learner tuning in today, especially if you don't work in IT or software, is because this specific fiction is universal.
Oh yeah, it's everywhere.
This painful separation of the mechanics of a job from the strategy of a job. Like if a machine can automate the mechanical execution of your daily tasks, the only human value you have left is in your strategic oversight.
Absolutely.
We are talking about software today, but this exact same paradigm shift is coming to legal contract drafting, to accounting audits, to marketing copy.
This raises an important question, though, and it's kind of the next logical step in the source materials argument.
Okay, what's that?
If the human architect isn't typing the code, if they aren't manually writing the instructions line by line, how are they actually communicating with this AI bricklayer to tell it what to build?
Right, because I know from playing around with basic chatbots that you can't just yell at your laptop, build me a secure banking app, and expect anything usable to come out.
Definitely not.
There has to be a structured way to hand over the blueprint.
And there is. The sources referred to this massive operational shift as spec-driven development. This is the methodology that is rapidly replacing traditional coding.
Let's break that down for someone who has never heard the term. What exactly is a spec in this context?
So spec-driven development is essentially the practice of writing the rules, behaviors, and logic of the software in human-readable formats, rather than in machine code.
Human-readable formats.
Yeah, the sources mention specific formats used in the industry, like Gherkin, or a more modern framework called OpenSpec. You are writing down exactly how the software should behave under various conditions. It's almost in plain English, but highly structured.
Can you give me a concrete example of what a Gherkin spec actually looks like? Because structured plain English sounds a bit like an oxymoron to me.
Fair enough. Think of it as a strict given, when, then format.
Given, when, then. Okay, so if you were building an e-commerce website, you wouldn't write the JavaScript for a shopping cart.
Right.
Instead, you would write a spec that says, given the user is logged into their account, and given the user has a laptop in their digital cart.
Okay, I'm tracking.
When the user clicks the checkout button, then the system should redirect them to the payment gateway, and then the system should reserve the laptop in the inventory database.
Oh, wow.
That is a spec. It is completely human readable. Anyone in the business can understand it, but it provides rigid logical boundaries for what the software must do. That makes total sense. And the guests in the video used a really brilliant analogy to explain why this upfront spec writing is so critical when working with AI agents.
Oh, the dartboard analogy.
Yes. They compared asking an AI to just build a feature without a spec to throwing a dart at a dartboard while completely blindfolded.
It's a fantastic visual.
Yeah.
Because when you just give a vague prompt to a language model, you are essentially spinning around blindfolded and throwing the dart.
Right.
You might get incredibly lucky and hit the bullseye,
Yeah.
but statistically, you are probably going to hit the wall or the ceiling or accidentally delete a database.
Yeah, and when you miss, what happens? You have to take off the blindfold, look at the hole in the wall, put the blindfold back on, adjust your angle slightly, and throw again.
It's exhausting.
It's a massive waste of time and computational power.
Yeah.
But writing upfront specifications, engaging in spec-driven development, is the equivalent of taking off the blindfold, walking right up to the dartboard, and pressing the dart as close to the bullseye as mechanically possible before you even throw it. You give the AI the spec, it generates the code, you review the output, and maybe you realize you forgot to specify what happens if the user's credit card is declined.
Right, which happens all the time.
So you adapt the spec, you add a new given when then rule, and you iterate from a place of extremely high accuracy.
What's fascinating here is how this methodology doesn't just make AI more accurate. It accidentally solves one of the oldest, most universally hated problems in the entire history of software development.
The documentation curse.
Exactly, the documentation curse. Historically, nobody wants to write documentation.
Nobody.
Developers want to build things, not write encyclopedias about the things they just built.
Yeah.
As a result, By the time a massive software project is finally finished and pushed to users, the documentation is already woefully out of date.
Because they changed the code 100 times during the build process and just forgot to update the manual.
Yep. But in spec-driven development, the specs are the documentation.
They are the documentation, and they're also the literal source of truth that the AI works from.
Yes, they are the documentation and the literal source of truth. The source material notes that with frameworks like OpenSpec, when a new feature is considered finished, the system takes those human-readable rules and merges them into an overarching running log of behaviors.
Wow.
The actual software must constantly comply with this running log. So as a byproduct of just building the software, you organically construct a perfectly accurate, beautifully human-readable set of rules that comprehensively describes exactly what your entire software product does.
I love the elegance of that. It just fixes the problem naturally.
It really does.
But I have to push back here on behalf of anyone listening who is currently managing an older legacy system.
Oh, the legacy code question.
Yeah. What if I am a manager who inherited a massive 10-year-old messy code base that has zero documentation?
Right.
It's basically digital spaghetti. Do I have to stop all my forward progress and reverse engineer some kind of massive Omega spec that maps out a decade of messy human code before I can even start using these AI agents?
It's a daunting thought.
Because if that's the barrier to entry, a lot of companies are just going to opt out. They won't have the time or money.
It's a very valid concern, and it sounds like a logistical nightmare.
Yeah.
But the guests specifically address this anxiety in the source material, and the short answer is a definitive no.
Oh, really?
Yeah, you do not need to create the Omega spec to start realizing the benefits of AI agents.
So how does the AI know what to do with the spaghetti code?
You just start using specs for your new features immediately. The underlying AI models have become so incredibly advanced, specifically their context windows have grown so massive that they can just handle the mess.
Wait, context window being the amount of information the AI can hold in its short-term memory at one time?
Exactly. A year ago, an AI might only be able to read a few pages of code at a time.
Right.
Today, models can ingest entire libraries of code in seconds.
That's insane.
So you give the AI your spec for a new feature. The AI agent will actively read your existing, undocumented, messy code base, figure out the context and the strange quirks of your system entirely on its own, and seamlessly weave your new spec-driven feature into the old architecture.
So essentially, the machine is acting like a brilliant senior developer who joins a company on a Friday, reverse engineers a messy 5-year-old code base over the weekend, and starts pushing flawless updates by Monday morning.
That is precisely what is happening. And the source mentions that if later down the line you feel the need to reverse engineer specs for the old legacy code just to have everything neat and tidy, well, you can instruct the AI to do that for you too.
It can just write the manual for the old stuff.
Yeah, it can read the old code and write the specs backward. But it is absolutely not a prerequisite to getting started today.
Okay, so we have the human writing the specs, and we understand the methodology of how we communicate the blueprint. But I want to get into the mechanics.
Let's do it.
What is the actual machinery doing the physical work on the computer? Because the source gets quite deep into the tooling, and for anyone trying to navigate this space, we need to clearly deconstruct the difference between the model and the harness.
This is a vital distinction, and it's where a lot of newcomers get confused. Think of the model as the brain.
The brain, okay.
This is the underlying artificial intelligence, the massive neural networks hosted on remote servers. We are talking about models like Anthropic's Claude Opus, OpenAI's GPT series, or the newer, highly efficient reasoning models like DeepSeek. The model does the thinking, the logic, and the problem solving.
And the harness.
The harness is the hands and the feet. It is the software interface that lives on your local computer, surrounding the model, and giving it agency to interact with your specific machine.
I see.
The sources mention popular harnesses like Aider, Pi, Claude Code, and OpenCode. The harness itself possesses zero intelligence.
Wait, zero intelligence?
None. It doesn't do any thinking. Its sole purpose is to provide the remote brain with the tools it needs to execute actions on your local hard drive.
Here's a part of the source material that genuinely fascinated me. The guests in the video were so intensely curious about how these harnesses actually communicated with the models that they did some digital sleuthing.
Yeah, they really dug into it.
They set up what is called a man-in-the-middle proxy. Can you explain for the learner what that actually means in this context?
Certainly. A proxy is essentially a toll booth on the highway between your computer and the internet. Normally, when your harness talks to the AI model's servers, that communication happens silently in the background.
Right.
By
Yeah.
setting up a man-in-the-middle proxy, these developers essentially wiretap their own AI tools.
They wiretap their own computers.
Yeah, they forced all the network traffic going back and forth between their local computer and the AI's remote servers
Yeah.
to pass through a window where they could read it in real time.
A lot of people tend to think of these autonomous coding agents as black magic. Like there is some incredibly complex proprietary binary code flying back and forth to make the machine operate your computer.
It feels that way.
But what they discovered on that wiretap was shockingly simple.
It demystifies the entire process.
They found out that it is literally just plain text going back and forth.
It's just text.
Just a text conversation. The harness uses a hidden system prompt to give the AI its identity. It sends a text file that basically says, you are an expert coding agent.
Right.
But more importantly, it gives the AI a list of simple text-based tools it is allowed to use. It tells the AI, if you need to change a file, reply with the text edit. If you need to see what's in a file, reply with the text read. Read if you need to run a command on the computer, reply with the text bash.
I should clarify Bash for our listeners. Bash is simply a command line interface. So if you've ever seen a developer typing text into a black window to make the computer do things rather than clicking on folders with a mouse, well, they're likely using Bash or a similar terminal.
Right. So if the AI model needs to know how many files are in a specific folder to complete the task you gave it in your spec, it doesn't intuitively see your computer screen.
No, it's blind.
It can't look at your desktop. Instead, it replies to the harness with a text message saying, use the bash tool to run a list command in this specific folder.
Exactly.
The harness on your computer reads that text, executes the actual command in your terminal, takes the raw text output of that command, and sends it back to the model over the internet.
Yep.
Then the model reads that text and says, I see there are 7 files in the folder. Now I know what to do next.
It is an incredibly fast, highly structured text conversation, looping back and forth thousands of times. And understanding this text loop brings us to a major debate in the development community right now.
Which is?
Which part of this equation matters more? The brain or the hands? The underlying AI model or the local harness?
And the consensus from the frontrunners in our source material is completely unambiguous.
It is. The model matters far more. The guests agree that well over 90% of the actual value, capability, and success of a project comes from the intelligence of the underlying AI model.
So the harness is really just a vehicle.
The harness is just a vehicle. Now, users might fall in love with a specific harness because they enjoy its user interface, or maybe they find its setup simple. Very much in the same way, developers used to argue passionately over which integrated development environment, or IDE, to use.
Oh, yeah. People fought over that.
Some loved Microsoft's Visual Studio, others swore by IntelliJ. But at the end of the day, a sleek interface doesn't matter if the brain behind it can't solve the problem.
Which leads to a very stark warning in the source material, specifically regarding how developers and companies are choosing their models. Right now, token costs are a massive topic of conversation.
Let's define token costs quickly. When you send text to an AI model, and it sends text back, you are charged fractions of a cent based on the volume of data. Those are tokens. The more complex the task, the more tokens used, and the higher the API bill at the end of the month.
Exactly. And because of that cost, a lot of people and companies are trying to save money by using older, cheaper models like GPT 3.5, or they are downloading smaller open source models to run locally on their own machines for free during their development process.
And the expert advice from the source is unequivocal. Do not do this.
Do not do it.
Do not shoot yourself in the foot by using inferior models just to save a few pennies, especially during your own initial learning phase with agentic development.
I understand wanting the best tools, but why is using a slightly older model considered so detrimental? I mean, isn't it good enough for practice?
Because you will inevitably get bad, hallucinatory, or broken outputs from the older models.
Oh, I see.
And human psychology dictates that you will attribute those bad outputs to the entire concept of AI-driven development.
You'll just blame the whole workflow.
Exactly.
Yeah.
You will sit there and think, oh, this technology just isn't ready yet. It's a gimmick. When in reality, the technology is phenomenal. You are just using an outdated brain.
That makes total sense.
The guests emphasize that you must experience the contrast. You have to tangibly feel the vast difference in capability between what a high-end frontier model can accomplish versus a lower-end one.
Right.
If you cut corners on the model, you stunt your own learning process, and you might just walk away from a revolutionary workflow entirely.
It's like trying to judge the safety, speed, and comfort of the entire modern automotive industry by test driving a broken-down, battery-depleted golf cart.
That's perfect.
You're going to conclude that cars are terrible.
Exactly. And to alleviate the financial anxiety, the source points out that the major frontier model creators, companies like OpenAI and Anthropic, are reportedly in the black regarding inference costs.
Meaning they aren't losing money every time someone runs a query.
Correct. It doesn't cost them more in server electricity to run the models than they are charging users. Coupled with the fact that incredibly efficient, highly capable new models like DeepSeek are constantly entering the market and driving competition.
The cost is just going to keep dropping.
The cost of tokens is only going to trend downwards.
Yeah.
It is a race to the bottom for intelligence costs.
Yeah.
So holding back your adoption of this workflow because of current cost anxiety is a massive strategic error.
So let's assume we take their advice. We are using the absolute best frontier models. We have our human-readable specs written perfectly, and we hook up our harnesses.
Okay.
Because these models are machines, they are incredibly fast, they don't sleep, they don't take coffee breaks, they don't get distracted by Slack messages.
Nope.
They must be generating a massive, unprecedented volume of code.
Oh, yeah, they are.
If these frontier models are as fast as you say and they never sleep, my immediate worry isn't capability, it's volume.
Volume is the new problem.
A human still has to read all this code to approve it, right? Aren't teams just going to drown in submissions?
That is exactly what is happening. The sheer volume of output creates a massive operational bottleneck, but it's occurring in a place the industry wasn't fully prepared for.
Oh, really?
The source notes that because writing code via agents is becoming so accessible, even product owners are now writing actual code.
Wait, product owners? For context, a product owner is usually the person who manages the business requirements, talks to the clients, sets the timelines. They are traditionally, emphatically not software engineers.
Yes, but now, armed with a good spec and an AI agent, they are generating functional software. And the result of everyone generating code at machine speed is a staggering ramp-up in what the industry calls pull requests.
Let's clarify what a pull request is for the learner.
Sure. In traditional software development, multiple developers work on different pieces of a project simultaneously. When a developer finishes their specific piece, they submit a pull request, which is essentially a formal proposal, asking the team to merge their new code into the main official code base. Historically, a senior human engineer has to sit down, manually read every single line of that new code, review it for errors or security flaws, and formally approve it before it gets merged.
But if an AI agent is writing thousands of lines of complex syntax in 3 minutes, the human reviewer suddenly becomes a massive bottleneck.
Exactly.
We physically cannot read and comprehend the code as fast as the machine generates it. Teams must be drowning in pull requests generated by their own agents.
They are. The human teams are completely overwhelmed.
So how do you solve that? I mean, if I'm the senior engineer and I literally cannot read the volume of code being generated, how do I know it works?
It's a huge shift.
Doesn't this break the whole system? I mean, I've seen AI hallucinate basic math facts. You're telling me we are just going to blindly accept AI code and merge it? Aren't we going to build a completely broken, fragile product?
This is where a massive psychological and operational shift has to happen for the human engineer. The source asserts that to survive this volume, the literal syntax of the code itself must become irrelevant to the human. You have to stop trying to read the code. What matters now is not the syntax, but the proof.
The proof? How do you prove code works without reading it?
Instead of a human reading line 12 to see if the internal logic looks structurally sound, you demand that the AI provide external, tangible proof that the feature functions exactly as requested in the original spec.
Okay, let's go back to our e-commerce cart example. How does the AI prove the cart works?
If it's a front-end application, the visual part the user interacts with, the AI agent literally runs the code it just wrote, navigates the application, and takes screenshots of the actual user flow.
Oh, wow, it just takes pictures.
It provides visual evidence. Here is a screenshot of the data being inputted, here is a screenshot of the button being clicked, and here is a screenshot of the correct success page loading.
And what if it's the back end, the invisible databases and servers? You can't take a screenshot of a server.
Good point. For back-end systems, the AI is required to provide the raw JSON network requests and the successful responses. JSON, JavaScript Object Notation, is essentially the standardized text-based language that servers use to pass data back and forth to each other. The AI shows the human the exact JSON text file it sent to the database, and the exact JSON text file the database sent back, confirming the transaction was successful.
I see.
The human engineer's job completely shifts. They no longer check the syntax of the code, they check the validity of the proof.
So we have specs going in and visual or data proofs coming out, which leads us to a concept in the source material that is genuinely a bit sci-fi.
It really is.
Here's where it gets really interesting. Because if humans aren't manually writing the code, and now, as you just explained, humans aren't even reading the code during the review process, we are entering what the sources call the dark factory.
The dark factory is a brilliant conceptual model borrowed directly from advanced physical manufacturing.
Right, like making cars.
Exactly. In a traditional 20th century factory, management had to pay to keep the overhead lights on so the human assembly line workers could literally see what they were building. But in a fully automated modern factory, where only robotic arms are assembling cars, robots don't need visible light to operate. You can literally switch off the lights, lock the doors, and the robots will efficiently keep building cars in pitch darkness.
And we are building a software dark factory.
Yes, we are. The frontrunners in the video state that they are actively trying to implement this dark factory architecture in their own engineering departments right now.
That's wild.
The vision is that human-written, human-readable specs are pushed through the door of the dark factory. Inside, AI agents take over entirely. They loop through tasks autonomously, using a mechanism the source refers to as the Ralph loop.
The Ralph loop. I need you to explain the mechanics of that because it sounds like we are just trusting the machine to grade its own homework, which seems inherently risky.
The Ralph loop, named by the guests after an innovator in the space named Jeffrey Huntley, who barely uses the handle Ralph, is fundamentally an adversarial AI setup.
Adversarial.
It's not one AI grading its own homework.
Yeah.
It is two distinct AI agents set against each other.
Oh, an adversarial setup. How does that work in practice?
You give the first AI the spec and tell it to write the code. Then you give the second AI a very specific aggressive system prompt. You tell it you are a harsh, unforgiving code critic. Your only job is to find edge cases where the first AI's code breaks the human's original spec. Try to destroy the code.
So they fight it out.
Exactly. They argue back and forth autonomously in this Ralph loop. The critic finds a flaw, sends it back to the coder fixes it, sends it back to the critic.
And it just loops.
They loop at machine speed until the harsh critic is completely satisfied that the code perfectly fulfills the spec. Once it passes that adversarial review, the AI automatically generates the visual or JSON proofs we discussed.
Wow.
Finally, the finished compiled software comes out the other end of the factory.
So in this model, the human engineer is just standing at the loading dock of the dark factory, handing a blueprint to a robot in the dark, and waiting for a fully built application to roll out on a conveyor belt.
Pretty much.
No human eyes ever look at the literal lines of code inside.
That is the ambition. Now, the guests are pragmatic. They admit they aren't at a 100% dark factory reality today. They can't just throw away an entire enterprise code base and flawlessly regenerate it from specs on a whim.
Right. No,
But the trajectory is clear, and they are moving incredibly fast toward that reality.
if the factory runs in the dark and AI is handling the coding, the reviewing, and the proving, why do we currently have software development teams made up of 50 people?
That's the million-dollar question.
What happens to the structure of tech companies when this dark factory goes mainstream?
Well, if we connect this to the bigger picture, we are looking at the death of the large Agile team.
That is a massive statement. The entire tech industry runs on Agile.
It does. The source explicitly compares this current moment to the tectonic shift that occurred around 2006 and 2007, when the software industry widely abandoned older, rigid methodologies and universally adopted Agile and Scrum frameworks.
Right.
We are undergoing a similar structural transition right now toward what they call agentic companies.
Let's define what made Agile teams so large in the first place. The traditional Scrum team was built on a very specific mathematical formula, right?
Yes, the classic Agile rule of thumb was a team size of 7 people, plus or minus 2.
7 people.
You needed roughly 7 individuals, front-end developers, back-end developers, quality assurance testers, a product owner, a Scrum master, just to handle all the manual labor of coding, testing, and managing a single feature from start to finish.
But having 7 to 9 people on a team introduces a lot of friction.
Massive friction. There's an old software engineering formula that calculates communication pathways. The more people on a team, the communication overhead doesn't just grow linearly, it grows exponentially.
Right, because everyone has to talk to everyone else.
Big teams mean constant meetings, endless alignment calls, miscommunications, and interpersonal friction.
But with AI agents doing the manual labor in the dark factory, that friction disappears because the people disappear.
Exactly. With highly capable AI agents amplifying human output, a very small team of 2 or 3 people can execute massive enterprise-level projects that used to require dozens of engineers.
The communication overhead just vanishes.
2 people can align over a coffee in 5 minutes and immediately deploy an agent army. And the source notes that major players in the U.S. tech sector are already acting on this realization.
Who's doing it?
They specifically cite Meta, Facebook's parent company, and Jack Dorsey's company Block as organizations that are actively restructuring their workforces and rethinking their team sizes based on the reality of smaller agent-amplified squads.
Which brings us to the elephant in the room. What happens to the guy who just genuinely loves writing C++ play?
Yeah.
The developer whose entire joy in life is writing beautiful, elegant syntax in their IDE.
The source is quite stark about this reality. They say that pure coders, the individuals who stubbornly refuse to let go of the manual act of writing syntax and refuse to learn agentic workflows, are in a highly precarious position.
Because writing syntax is suddenly incredibly cheap.
Yeah.
One of the guests made an economic comparison that completely blew my mind. He stated that writing code using an AI model is now literally cheaper than flipping burgers at a fast food restaurant.
It sounds hyperbolic, but the math supports it.
Let's look at the math. Even factoring in the cost of API tokens we discussed earlier, the machine can generate an entire functional web application in minutes for pennies.
Pennies.
If you compare those literal pennies to what you would pay a senior human developer in salary and benefits for the hours or days it would take them to write that same code by hand, well, human coding is economically unviable for standard projects.
It is a harsh reality, but the market will always relentlessly trend toward efficiency.
It makes me think that writing beautiful, perfectly formatted, highly efficient code by hand is going to become an artisanal hobby.
Oh, that's an interesting way to put it.
It reminds me of a colleague I know who makes wooden furniture by hand in his garage. He uses hand planes, he cuts his own joinery without power tools. The furniture is gorgeous, it requires immense hard-earned skill, and people deeply respect his craft.
Sure.
But it is absolutely not how mass market shares are produced for the global economy anymore. Manual coding is becoming an artisanal craft.
That is a very apt, though sobering analogy. The mass production of software is moving to the automated dark factory. Therefore, the engineers who will survive and thrive in this new era are the ones who shift their focus. You can no longer focus solely on building the product. You must focus on engineering the process that builds the product.
You have to manage the factory.
You must become the manager of the dark factory.
Okay, so with all this massive disruption, how does someone actually survive this transition? If you are listening to this right now and having a mild existential crisis, realizing your hard-earned skills might be becoming artisanal, what is the action plan?
The guests in the video emphasize one critical intrinsic quality that separates those who adapt from those who don't. You have to find the spark.
The spark. That sounds a bit esoteric for a highly technical discussion. What do they mean by that?
It's an internal, almost obsessive curiosity. It's a drive to experiment with these AI tools daily, not just when your boss tells you to. They talk about teaching workshops to enterprise teams, and they can instantly see it in the room. There are always a few attendees who just have a fire to explore.
I want to break the tool to see how it works.
Exactly. You cannot force this spark, but you absolutely need to cultivate it to stay relevant.
And when you do find that spark, the source suggests it is an incredibly intense experience.
Very much so.
There were some crazy anecdotes in the video. One guest talked about waking up at 3 a.m., completely unable to sleep, because he suddenly had 10 ideas for complex applications that he realized he could build instantly.
Right. He described the feeling of discovering agentic development as experiencing free cocaine.
Which is an intense and slightly alarming way to put it.
Very intense.
But his point was about the neurochemistry of creation. He was talking about the endless dopamine hits you get from rapid unblocked building.
Yeah, because for years, every software engineer has had a mental backlog of someday projects.
Cool apps or tools they thought they'd build on weekends or when they retired.
But they never had the time because the manual coding took too long. Suddenly, with an AI harness, the barrier to entry is gone. You can build those backlog projects in a single weekend. The speed of innovation becomes intoxicating.
And they draw a very direct historical comparison. They liken this specific moment in time to the advent of the commercial internet around 1995.
Exactly. There were plenty of smart people back then who thought the World Wide Web was a fad, who asked, why do I need a website? The phone book works just fine.
Oh man, I remember that.
But the train was leaving the station, and the source is adamant the AI automation train is moving exponentially faster than the internet adoption train did.
You either hop on, experiment, find that spark, and learn to manage the agents, or you will get left behind and eventually become professionally irrelevant.
That's the reality.
But here is the most important part of this entire deep dive. It is not just tech companies and software engineers that need to get on this train, is it?
Not at all. And this is perhaps the most exciting and disruptive part of the entire discussion. If we connect this to the bigger picture, the real frontier for AI agents isn't just software developers engineering faster workflows for themselves in Silicon Valley. The massive, entirely untapped opportunity lies in non-IT businesses.
The mid-sized companies out in the real world.
Yes. The guests specifically point to mid-sized traditional businesses that are currently drowning in what Google famously coined as toil.
Toil. It's such a heavy descriptive word. We are talking about the repetitive, soul-crushing administrative work that keeps businesses running but doesn't actually produce new value.
Exactly. I want to paint a very vivid picture of what this looks like, because this is where the economy changes. Imagine a mid-sized regional logistics company. They have 50 delivery trucks. Right now, the entire company is likely being held together by a warehouse manager using a complex, incredibly brittle, 10-year-old Excel spreadsheet loaded with macros.
Oh, man.
If someone accidentally deletes the wrong cell, the entire dispatch system crashes.
We all know a company running on a terrifying spreadsheet like that.
Right. And historically, that logistics company is trapped. They're too small to afford a dedicated in-house software development team to build them custom tracking tools. That would cost hundreds of thousands of dollars.
Right.
But they're too big and complex to keep relying on fragile Excel macros without risking failure. They are stuck in toil.
And this is exactly where the AI agents step in and change the game.
Because the cost of generating code has plummeted to less than the cost of fast food labor, that warehouse manager doesn't need to hire a dev team.
Wow.
That manager who understands the business logic perfectly but doesn't know a single line of Python can sit down and write a spec. They write the given when-then rules of how their dispatch system should work. They feed that spec into an AI agent on their computer.
And the agent just builds it.
And the agent automatically generates a perfectly functioning, bespoke, highly secure internal web application specifically tailored to that logistics company.
That is profound. We are talking about the complete democratization of custom software engineering. The local plumbing supply company, the regional accounting firm, the mid-sized logistics fleet, they all suddenly have access to the same software engineering capabilities as a Silicon Valley startup for pennies.
Exactly. They won't need to hire a Scrum team of 7 developers. They will just need one employee who possesses that spark, who can write a clear, human-readable spec, and who knows how to run a local AI agent. The agents will systematically eliminate business toil across every non-tech sector.
Okay, let's bring this all together for the learner listening today. The takeaways from this source material are staggering. First, the mechanical act of typing code is effectively solved. It is the bricklaying of the future. Engineering, the conceptual architecture, is more critical than ever. We are rapidly moving from manually writing syntax to writing human-readable specs. Those specs are feeding into automated dark factories where adversarial AI loops write, review, and test the software autonomously, generating visual proofs for humans instead of code to review.
And operationally, this is causing the death of the large, agile team, pushing the entire economy toward leaner, agentic companies where incredibly small human teams wield massive output capabilities.
So for the listener, whether you are a senior developer at a tech giant or a manager staring at a broken Excel spreadsheet in a warehouse, your immediate practical application is this. Tomorrow morning, look at your daily workflow and ask yourself, can I do this task with an agent?
Try it over and over.
And when it inevitably fails or gives you a weird output the first time, do not blame the model. Assume the failure is your prompt. Assume your spec wasn't clear enough, adapt your instructions, and iterate. You need to cultivate that spark of curiosity before the train leaves the station entirely.
And remember, the mechanics of almost every job will eventually be automatable. Your long-term professional value lies entirely in your overarching strategy, your domain knowledge, and your architectural thinking.
Which brings me to a final, slightly provocative thought I want to leave everyone with.
Okay.
We just discussed how AI is going to eliminate the toil of those brittle Excel spreadsheets in non-tech, mid-sized companies. We are talking about a world where warehouse managers use AI to build custom web apps. But if AI agents can take raw business rules from laypeople and output perfectly functioning internal software without human coders, does that mean every single company is about to become a software engineering company without actually hiring any software engineers?
That is the logical, inevitable conclusion of the dark factory model.
And if that happens, if the entire global economy is running on millions of bespoke applications generated in seconds, and if no human eyes are ever looking at the literal lines of code inside these massive automated dark factories, what happens when a hallucination, a tiny subtle AI misunderstanding of a spec, gets hard-coded into the foundation of our entire digital infrastructure? We might not need to read the code today, and we might be celebrating the speed of creation, but will we even have the capability to read it tomorrow when it breaks? Think about that the next time you open a spreadsheet.